Thanks everyone for joining today. Today we'll be talking a bit about our latest polymer material, smooth TPU 95A, which is a bit of a stretch from our origins in strong composite parts. So TPU, thermoplastic polyurethane, is a rubber-like material used to produce flexible, impact-absorbent parts. When you think of things like gaskets, seals, shock absorbers, hoses, drive belts, TPU is one of the few materials used to produce those parts. Markforged Smooth TPU is a 3D printing filament that provides the same functionality of traditional manufactured parts while giving you the capability to easily produce custom designs on demand at the point of need. So it's a lot of the same value proposition that you know for onyx, that you know for continuous fibers, for metal, but we've sort of gained a new functionality here. It's different than that strong part that we're used to seeing. So before we introduce the new material, I guess we ought to introduce ourselves. So I'm Charles Liu, application engineer based out of Markforged headquarters in sunny Watertown, Massachusetts. You might have seen me on a number of videos and webinars over the years. If you have, I want to especially thank you for joining us again, despite having suffered through one or more of my 60-slide rapid-fire monologues on CFR, supply chain, resilience, or software enhancements. It means a lot to the Markforged team that you took the time out of your day to hear what we have to share. Today we're joined by a special guest, Charles Renegar, who is a manufacturing technology engineer and a Markforged customer. Charles participated in the Smooth TPU Beta Access program and will share some thoughts with us today on that. If all goes well, I'll leave most of the talking to the new and improved Charles. So Charles, tell us a bit about yourself. What does a manufacturing technology engineer do?
Yes, so being a manufacturing technology engineer, I wear a lot of hats, support our production lines on a day-to-day basis in a way, kind of helping out with our process engineers, work on new technology introductions, so new products up and coming, as well as kind of new equipment installations and things like that. So it's a lot of kind of cutting edge things. And then also a portion of my role is to support our additive manufacturing program here at the facility I work at.
Awesome. How long have you been working in additive?
Yeah, so I've been in additive, I would say since 2014, but really started as many other people do with kind of consumer grade printers, kind of dipping our toes in the water. We kind of jumped up into more industrial printing capabilities in 2018, and started as Markforged customers in 2019. Actually started with a Metal X as well as the Mark II, and have graduated up to multiple Metal X's and now FX20 at our site.
Awesome. Oh, yeah, so you have the FX20 also. That's pretty sweet.
I do.
You really got the whole gamut of products there. Today's agenda, we'll talk a little bit about the Smooth TPU material. We'll do a bit of an overview on that for anyone who hasn't taken a look at the website yet. We'll talk about Charles's experience printing TPU so far, have a discussion around his application specifically, and how Markforged TPU fits into that scenario, and then we'll take questions. So I see a number of questions already, and so we'll probably pause somewhere in between to answer some questions, maybe about halfway in. So we'll start with the material overview. Markforged was started in 2012 to make 3D printing more functional through strong parts. We have novel technology to print with continuous fibers and have since grown to cover a wider range of functional materials, which includes plastics, continuous fibers, and metals. Charles, you said you started with metal, right? So that's there are a lot of different places where you can start, and a lot of different applications for the technology. It's obviously going to be different for every customer. So since the Mark I days, the footprint of the desktop printers really has remained the same, but the capabilities can continue to improve through hardware, software, and materials. Each new material we release is qualified by our team of material systems print engineers to work on the platform. So these materials are subject to thousands of collective hours of printing to get the settings dialed in. We test on a multitude of machines with varying age, maintenance condition, from new to like really kind of old and busted. And it's not, I'm not going to say that we like intentionally make them old and busted. Sometimes we just have a number of those, but I'll say that that's so that we can be sure it works on day one for you, regardless of what condition your machine's in, or at least within a certain range. So as you use the new materials and send us feedback through support or Eiger, we have another team of engineers dedicated to quality, which triages some issues, prioritizes and develops solutions, and releases updates and improvements over time. So we prioritize material development based on customer applications. Our intention is to produce a tool, the tool being the printer, which helps you as engineers solve the widest range of problems possible, without generating too many new problems of their own. If you're familiar with some other 3D printers, you can maybe surmise that sometimes they come with a number of problems on their own as well. So getting that right can take some time, and that's why we depend on customers like you and Charles to provide us feedback on our materials, not just in our print test suite parts, but in real applications. So for seals and gaskets, for example, I got a question about this yesterday via email reply. We want feedback on how these parts seal in real scenarios. Does thickness matter? What print settings make sense? Will the seam get in the way? And should we consider post-processing? We want to take some feedback as we go, and we'll continue to improve as we move along. Smooth TPU is really meant for design validation of end use, from anywhere from design validation to end use parts. Whether you're validating designs of parts which you'll make in a traditional method or in another method, or whether you're trying to replace legacy parts, or designing for a future production, this TPU really is intended for a range of applications, not just prototyping, not just end use. It's kind of meant to fit the whole gamut. I'll do I don't think I'm going to run through the data necessarily on these, but we have mechanical properties available to download on the website. So I actually noticed that it wasn't showing up in the datasheet section and fixed that yesterday. If you go to the datasheet section on the website, you'll be able to download the Smooth TPU datasheet. You can also go to the Smooth TPU webpage and download it from there. So we'll have mechanical properties, and we'll continue to have more over time as well. So I saw a question around heat deflection temperature. TPU is kind of funny in that the heat deflection temperature isn't. It's like technically it's already, most of the TPUs are already past their deflection temperature maybe. It depends on which loading condition you're using, but we have some characterization of performance under different temperature conditions, which we'll be able to share with you. There's also chemical compatibility. I've gotten some questions around this as well, essentially like whether it's ether or ester. I think we have some sort of agreement where we're not going to say exactly which one it is, but if you look at the chemical compatibility, you can sort of figure that out. So if you need chemical compatibility, the chart, send us a message and we'll get in touch with that. We're going to move on and talk a bit about Charles's TPU printing experience. So I've got a few photos from your AM lab, and let's bring that up on the screen, and then we can talk a bit about how things have been going. This is the lab. What's your workflow like? How many users do you have in there?
Yeah, so we, it's tough. I'd say we have about 18, 20 users, probably a handful, 5 or 6 that are really heavy users of this lab. Kind of ranging all the way from, a handful of expert level people. We've got a handful of people that are more or less kind of printer operators, help keep the workflow going. So kind of all ranges, but it really busy, really busy lab. Everything you see there runs a lot, especially the Metal X's, the Mark II, getting up and going on the FX20, but they're all very busy machines. Yeah, I considered cleaning it up quite a bit for these photos, and I was like, nah, let's let everybody see what it really looks like. But it's fairly, it's not a huge lab, but plenty of space, plenty of workspace to work on parts. Some metalworking tools and things, so it's pretty functional. It works well for us.
That's awesome. I noticed you don't have an X7 in there. What's going on?
Yeah, a lot of it was holding out for the FX20, and we have several of them in the company. We do a pretty good job sharing print capacity, and I leaned on other people when my Mark II was overflowed, which was a lot of the time. So yeah, just fortunate to have others close by that can ship me parts with X7s. But we're That's likely next on our list.
Yeah, that's the I guess the beauty of working in a company with multiple departments. You've got, yeah, if you have that good cross collaboration, um, yeah, not everybody needs every machine. You get what you need, right?
Yep.
So how did you end up in the beta program? For everybody who's on the call, I wasn't actually part of that beta program. So you worked with a number of people here, right? So tell us about that.
Yeah, so have and have all kind of since jumping on board of Markforged, have had a pretty good relationship. Like I said, started with the one Metal X. I got the Mark II with it, and then started using it right away, and then connected with some of the strategic folks at Markforged, and really on the beta side, we were talking more FX20 than TPU originally, and there was some interest because of our print volumes and looking for a bigger printer. We were working kind of on that side, and then the idea got brought up, hey, do you ever print in TPU? And I did have some capability to print in TPU and had some parts and some applications. And it's kind of funny, we'll get to more of it. I've got this guy sitting here. I had one application that I couldn't get any of my current printers to print, and I had this floppy fall apart thing. And it's like, man, I just really want to be able to print it. It's something I could use. And they're like, hey, send the file over, we'll give it a try. And then they sent me back you know the part I wanted. And so it was really just the fact that I had an application laying around I was struggling with, and Markforged was able to get it done. And it's like, well, hey, this will be a great partnership. It's really, I think, how it kind of all developed.
Yeah, that's awesome. So what were you printing with TPU, and what were you like? Yeah, how long had you been trying to print it? Like, what was that experience like before
Yeah,
you
so
would start
it's
stuff?
yeah, so we've it's one of those applications I probably use compared to the rest of our printing, pretty low volume. It's like once a month or something, we'll have a need here or there. We've had some needs for flexible boots and things, kind of the parts you immediately think of, and have had some success even down through consumer grade printers, printing TPU, but with a lot of tinkering and a lot of issues with just controlling the moisture. We have TPU capability on our other machines. They're pretty point and shoot, but not a lot of flexibility in settings either. So it's a material we've had around. We tend to have needs for here and there. Like I say, I've made gaskets, a lot of valve seats. I've made a lot of just really simple kind of shaped parts, but you need something really tough. Some can take a lot of abrasion, a lot of abuse. It works out really well if you can either use the flexibility, don't mind the flexibility. These parts are really hard to tear up.
Yeah,
But
yeah.
just in a factory environment, it's a great fit.
What's has the 95A been working for you? Like in the past, did you use more flexible, less flexible? Like, what was that like?
Yeah, most of what I've had has been kind of similar to a little bit less flexible. A lot of times I need a little bit of extra flex over the just base 95A, but even just the default, most of the default settings are not solid parts, so you're going to get more flexible pretty easily with it, and it honestly gives you some freedom to do more with it. So if you even something like I've got some little brackets and stuff here that are really simple. Maybe we can show that. But oddly enough, you can build wider sections that get the triangle fill, and then have a narrower section that just gets all walls. And you can have something that, even though it's thinner, is more solid. You can get it to flex where you want it. So I mean, it's just playing with print settings. You can do a lot with it. We've been really successful so far.
Awesome. I think we've got a number of questions in the chat, and yeah, one of the questions are on heat deflection temperature, which Cade, we'll get back to you on that. I think there's still some ongoing testing to characterize it. Like I was saying, it's not exactly here's the temperature and we got an answer. I think we would rather give a range of performance to be a little more clear about it. I think you can get equivalencies through different heat deflection temperatures, but I think it it's like as a single number might not be as clear as we want it to be. Charles, have you used it for any seals or gaskets yet? It seems like a lot of people are interested in doing that, but I'm wondering if you had any personal experience.
Yeah, I've got at least off of the Mark II so far. I've got one application I've used, and it's a valve seat, and kind of just a plunger type valve where we've replaced the main puck. It's about a 3.5 inch, 4 inch diameter, and yeah, it just seats up against the valve, and it works really well in that application. We're not moving anything liquid; it's solids through that valve, so it doesn't need to be, I guess, perfect sealing, but works well. I haven't done many just pure gaskets. A lot of what I work with is high temp, so I use a lot of silicone. So just so happens to be outside the temp range of what TPU fits for.
Yeah, that's totally fair, and I think that's similar to what I've seen as well with like a printed. You've got a couple options when you need a flexible material. You can print a mold and cast it. You can cut it out of a sheet. The printed part, I think, for a gasket specifically, it's as you're saying, it's a lot of stuff that's near high temperature environments. I think like even like
it is like those valve seals. There's, even though it's a pretty simple part, you start to get some unique geometry. You're not going to try and carve out of a block of it or even machine it. It's too flexible to do it or do it well. So that's where we start seeing the printed parts sneaking in, is where that's the more efficient method to get there.
Yeah. I think there was another question around validating the flexibility of parts on certain applications. So that's like we've got our way of testing a bunch of samples and doing bend tests and stuff, but and doing the shore hardness testing. But what have you done to adjust infill, etc.?
Yeah, so you probably noticed on the left hand of that picture there that I do have the shore hardness tester sitting in there. So there are times when I use it, but for me it's more functional. I've got a part here, insert for flex coupling. I've got two different fills. I've got a lot of this was just tested practically. I wanted a certain deflection under load, and we just tested it in application. And that's more often than not okay for the applications I'm going for. And it's a lot of times because I can print it, and I can't. When I made this one, I immediately made 3 or 4, so I could easily swap out and try, because it's honestly didn't know what I needed. And test them more, like I said, either directly in application or come up with a way to test it. For that one, we needed 10% deflection roughly, so we loaded the machine once it was installed, just to kind of see what we got before we ran product on it.
There's a question about those gas tanks in the back. I guess there might be some folks who aren't familiar with Metal X. Those are just for Metal X, right?
Yeah, that's correct. We have the Center 2. Because of the 2 Metal X's, even had it with the 1, because some of the parts we do are pretty large. But so it's the mixed gas, and that's an argon cryogenic cylinder, which works well for us due to space to supply that Center 2.
I think there is still a number of questions in here, which we'll get to in a bit. Thanks everyone for hanging on. The next thing we'll talk about is like your specific application. I think it's a pretty interesting one, and I'd love to hear from you a bit more about how things have gone with that, like the testing procedure, and how you got to your new design.
For sure.
So this is the part. Tell us what it is.
Yeah, and even before I go into that, like I'll preface this. This is one of my favorite kind of projects. Like super simple part. One of those somebody just walked up and said, "Hey, what if?" And we tried it. So the part on the left in red, it's essentially a rubber band. This is an older machine that this goes on, and that is a chuck that holds a cardboard core. We produce film materials here. We're winding film on a cardboard core, and when you rotate that, it expands out. So there's kind of 3 teeth on a cam mechanism that expand, and that rubber there interfaces with the core to provide grip. It also holds all those teeth from falling out. So kind of 2 functions. And as those either wear, they get kind of slick and get hard. Sometimes they break, and just had generally issues with it slipping in use. So as we apply tension to this film, it would slip. So somebody was like, "Man, I wish I had some kind of texture to it, something to grip into that cardboard to make it work better." And that's where a couple of features, a loop with some teeth, and that's the black part you see on the right, which is actually the first one, dangly part I held up. This is actually the first time we tried it on another machine, and it just didn't have enough layer adhesion and couldn't find settings to get it. No matter how many times we printed, they came out like this. Or I could make it really thick and it would print, but then it wasn't flexible enough to expand and do the job. So that's, when I got this part back from, well, hey, Markforged, can you try and print this? And they sent it back. It's like, oh my goodness, here we go. We get to finally try this. But actually, I don't know if the difference will show up here. What we ended up with was this white version, which is half the thickness, even more of the original, to give even more expansion and even better grip. So this was like version 2, which once we were in the beta program, we started printing these, and then 2 days later we started printing those to improve upon that. Immediately saw benefits on the machine with both grip to the core and durability. But these actually last longer than the original part. The other thing, I guess, to notice, I mentioned this is an older machine. The original belts that were used are long since you can't get them. We were buying a kind of a stock rubber band to do that application. That's why on the picture on the left, you can kind of see some gaps that didn't fit that well, or these we can size them appropriately. But even then, this one has enough grip. If I flip it inside out, we start actually seeing it slip on the metal teeth and start iterating design again. Ended up with one that's even thinner and has 3 rows of grooves. Again, probably doesn't show up well on the camera, trying to show them. But really just kind of throwing all these out there to go, all right, somebody had an idea that was like, hey, what if we did this? It worked. And, within a week, I'm sitting here with 3 or 4 designs, continually improving upon it. And on a machine like this, we were just using what we could get. So I love these applications where you just unlock a door to innovate on something you never would have thought, and improves the performance, improves the reliability. It's really cool.
Yeah, so you're using it as a manufacturing support equipment, essentially, right? It's like
yeah. So I'm making the replacement parts, but at the same time, I'm making it perform better.
Yeah, that's awesome. Yeah, it's good to see when I fix stuff around the house. That's like my job doesn't entail having to make real fixes here, but like there are certain things where you get into a scenario where some legacy part has whether it was just the way it was designed or it's time that's taken its toll on the part has caused it essentially to stop performing as well as it needs to keep up with your day-to-day operations. So it certainly is nice to have a tool that allows you to address those problems. So I guess there's a related customer question here, or sorry, a related question here. Someone's asking if it's plug and play with TPU. Did you have to modify any settings to get it to print?
No, so it was pretty plug and play. I'll say pretty plug and play and have a slight hesitation. Not so much that there's any reason to hesitate, but our Mark II gets a lot of hours. When you mentioned earlier, you got some headquarters that are kind of broken down and beat down. We run a lot of Onyx, and we had gotten really behind on a lot of our maintenance. I had a nozzle that was probably twice its recommended life. I had a hole in my Bowden tube. I didn't even realize it. So I get TPU, I loaded it up, and the first thing it did was start to jam, wouldn't run. I'm like, man, this is tough. And kind of look around and go, all right, my printer's in pretty rough shape. I've been way pushing my maintenance schedules. So it was like, threw a new nozzle in it, replaced a Bowden tube, and I have not had a failed print since. It's just rock solid. The one noticeable difference for me is the bed adhesion is a little less. than what I'm used to with Onyx. If I've got like these really thin brackets and print them on edge, like these print way better with a brim.
Yep.
You know, there can be some peeling and stuff like that. But if you're just mindful of slightly lower bed adhesion, that's been the only noticeable thing for me. And another thing to note that I really didn't expect is, you know, my other systems, when I run TPU, it tends to be an all or nothing. You know, I run that spool, it's usually ruined by moisture before the print's even over. Even ones that have kind of dry box kind of setups. With this one, even just the bag it comes in, the size of the spool, I can reuse these things. I can put them back in their original packaging, come back 2 weeks later, load it up, it runs. And it's the only machine I've had successful rerunning TPU spools over time. So it was, you know, a little bit of attention to detail for me on the printer maintenance side, and then it's been flawless.
Yeah, there's a bit of a difference in the utilities as well, right? There's like a
Mm-hmm.
yeah, I used it recently, and there's a cold pull. Yeah, what's that been like for you?
Yeah, so coming to like out of Onyx into TPU, there is a purge procedure.
Mm-hmm.
You know, nothing too difficult to do. And you know, if I'm in a really big hurry, I'll just swap nozzles. You know, that you can expedite it a little bit, but you know, it takes honestly 2 minutes at most. No change in hardware, no recalibration, which is probably the biggest headache coming off of some of my other machines is you got to swap the heads, so you have to recalibrate it. For this one, you don't. At the end of the print, you do a cold pull, which I did learn. You know, it works better if you pull the print head to the front of the printer so that your Bowden tubes aren't stretched out. I did damage a fiber Bowden tube at one point through this, but it was, you know, just learning, handling the printer myself more often. But yeah, really straightforward. And then going back from TPU to Onyx is, you know, essentially just loading material. You know, really easy back and forth.
Yeah. Have you printed any parts with supports?
I have, and they incredibly peel right off, and that blew me away. You know, other systems, even using soluble support, the soluble does not peel off. You must dissolve it, and then, you know, if you do a non-solid part, they tend to get full of that. You have to let them drain and dry for a day before you use them. A lot of times coming out of that tank,
Yeah.
and where it sounds convenient, it's honestly adds a whole day to getting your part. Where for these, I've even had some pretty, you know, encapsulated, you know, where we had grooves cut into a part and support in it, it peels right out. It's a similar experience to printing with Onyx, you know, minimal adhesion of the support.
Yeah, I've also been pleasantly surprised with some of the prints that I've seen. It like I knew from Onyx that we do a type of an offset, right? Like there's an offset of the support from the surface, and we're actually doing sort of, it's like tacking almost. When you look at on a slope surface where the part is connecting to the support structure, it's not it's not like a block of connection. They're like, it seems almost like strategically spaced so that you're able to tear it away. And I noticed, at least with the TPU supports, that they really just kind of peeled right away. I'm wondering
Yeah.
if it has some function of the support kind of shrinking towards itself and the part shrinking towards itself. As you know, when it's heated, it's like it's kind of melty, right? So I'm wondering if that has something to do with it.
Yeah, for sure. And like I say, that it's the tack level between the support and the parts pretty low, but the toughness of the TPU, it comes off in like one piece every time. So it's it's pretty convenient. But like I say, just no more than a pair of pliers ever really needed for some of the more difficult ones.
Yeah, that's a good point about the toughness. I remember a couple years ago when we had some Onyx parts that had internal channels, and they were not exactly the most fun to clear. It was like a couple benchmark parts that we had where we had a channel kind of going through the part in and around, and it ended up being pretty nice to wait a little bit, right? Onyx, as it absorbs moisture, gets a little tougher, so we would just leave it for a couple days and then go pull it. And instead of the support structure kind of breaking into different pieces, it would be tougher. That's what you said about the TPU support is definitely true. It's not going to break into separate
Yeah.
pieces when you go to remove it. Cool.
Yeah, and I mean, honestly, and that's where we're using it. Like these little brackets I keep picking up. These were in a location where they get wrecked into by other parts, and every other material you just crush it. But it didn't matter if it flexed a little, and that's where we ended up with TPU. And these are, actually have enough wall thickness. They're solid. So we're using kind of the full 95A, and yeah, you can run into them all you want. They're not going to break.
Yeah. There's a question here from Eduardo. He's asking what's the lifetime of the TPU belts versus the originals, you think?
Ooh, if I just had to throw a number, I would say I would guess it at 2x. I've never broken one of the printed ones. I don't know.
Yeah.
We've changed them out to look at them. But even these that I'm holding up, these have spent months on the machine, and we've traded them out for different designs. So it's like, well, I don't know. Looks great. The teeth are even still sharp.
Yeah. Cool. And there's a question here that I'm just going to jump into. Is TPU going to be available for the X7? This is David's question. Yes. So we're actually planning to bring TPU, like we did with PLA. TPU is also going to come to the X7. Just for everyone who's not aware yet, this does require that A3648 extruder, which is the extruder that comes on the Gen 2 units. That is required to print the material because we're taking feedback from the system to tune the print. So it is required, and it has a little bit more pushing capacity. Cool. And I wanted to talk a bit about like your experience printing other TPUs. And I've got a photo here, which I guess you've also got. Yep, those are the parts. So
Yeah.
What was that like? And like I'm curious what your experience has been like. And for anybody who's in the audience, if you've printed with other TPUs, throw that in as a question and let us know. But yeah, Charles, tell us about your experience.
Yeah, at least for me, the biggest variable that I struggled with on other printers when I printed, consumer grade it was always problems with stringing. Yeah, I've seen a lot of that, which I don't see on the Mark II. With this one, it's layer adhesion. Not so much in the Z, but actually in the XY. I think a lot of the settings that produce good surface finish don't always produce good layer adhesion. You're almost under extruding to make a part look good. At least that's what it felt like with some of these features, or just, some of this could even be slicer related or different things. But again, like I said, with going to the Mark II, I haven't had to worry about that. Even with these really thin, highly detailed really parts, I've pushed it so thin that I've seen a little bit of stringing. If I just really push the geometry, this one's less than a 16th inch thick. But yeah, that's honestly the big difference for me is there is no tinkering, and the level of surface finish is better than I've seen on any other platform so far. At least from an FDM perspective, I'll put it that way. I haven't seen parts that are this clean coming out in TPU. I'm used to them just being, a little rough and having some stringing, and that's not the case.
Yeah, that's good to hear. And I think my experience of with TPU was probably a long time ago. It was back when I was was in school, and that was like kind of early TPU. The moisture was a problem, right? That like you're saying, the moisture feels like the biggest problem that you encounter when you're printing it, because if you start absorbing moisture in the filament, like you're going to have adhesion problems, you're going to have extrusion problems, like the material's going to expand.
Yep. And I mean these printers are already set up to deal with it, so it just works.
Yeah. I wanted to talk to you still, Charles, a bit more about just how your experience has been overall with Markforged. Is there anything that we can do? You can put us on blast here publicly. How's it been? Anything that you'd want to see from TPU or other materials?
I mean, honestly, you guys are doing it. it's been a great partnership for me. And, and some of this is just fortunate as far as, when I came to Markforged, I mentioned coming Metal X first. 17.4 is a material I used in machine parts out of frequently. So it was a great fit. Um, got on with the Mark II by chance. It was a package deal with our first Metal X. It wasn't really even on my radar. And that first year, I ran the Mark II more than the Metal X. As soon as I started seeing the ability to replace those aluminum strength parts, overloaded the Mark II right away. So it performed really well for that, as well as just making really good looking parts, surface finish wise. And then kind of the same thing here with TPU. It's the parts fit the application, and even jump into FX20. The Ultim and the higher temp filaments, there's something that I was using on other platforms and was a need for me, as well as the scale. So it's just been a really good fit for our applications. And I think that's probably very true in a lot of industrial applications. It works on a factory floor really well. I'm sitting there going, what's my wish list? I want even higher performing polymers. Higher temperature, even than the Ultim 9085 is on my wish list. Other than that, I'm really pleased. I don't know. You gave me the opportunity. I can't think of anything bad today.
Oh, I'm thankful for that.
Yeah.
Whatever bad slipped your mind. High temperature polymers I think are pretty interesting too. TPU's not that, right? It's a lower temperature polymer. I don't know if there's a printed flexible polymer, but yeah, as far as like stuff that's like Ultem, higher temp than Ultem, that'd be like, are we talking like Ultem 1010?
Yeah, 1010. Peak is a material I use pretty frequently. So yeah, and that's a lot of it's just the industry, plastics kind of industry I support as the temperature ranges we work in.
Yeah, that makes sense. If you're making polymers, you're going to need something that holds up to higher temperatures than those polymers. Yeah. There's some questions here around, I think, which you might be able to even help us answer. We've got a spec sheet number, but I'm curious about your experience. What's the minimum feature size that you can print, or that you'd feel comfortable printing?
Oh, goodness. I'll be honest. What I'm seeing is if you're doing it in Onyx, TPU is fine. I haven't had any, and that's, I don't know, trying to come up with a number off the top of my head. The one part I've got on hand here where I've kind of pushed it, and I've seen, a little bit of stringing, but the part's still functional. This thing's, I don't know if you can even see the grooves in it on the camera there. These things are less than a 16th inch features, all over that part in a pattern. But yeah, generally it's comparable to Onyx.
Yeah. Have you, on the internal view, when you're looking at a 2D section, what's the smallest number of rings that you've gone to? Have you done like a two wall, a single wall part yet, or is
I've done two wall parts, and those come out fine. I haven't gone down to single, and certainly wouldn't recommend it. I've actually stacked these things and printed multiple, and got height to them and done that. To try at your own risk, for sure. But it's worked for me.
Is it putting another support layer in between? Is that what's happening?
Yes, I'm doing that in CAD and leaving a little air gap where I put support and just peel them apart.
Yeah. Okay. That's cool. I like that. Right. Yeah. Rather than being constrained by your XY footprint, start building up. And
I guess one thing that's probably worth mentioning also is I said it prints really comparable to Onyx. It's also really compatible, where I've got some like multi-body, like badge holders and stuff, where I've got an Onyx part, TPU part, embedded. And I don't have to play with scaling. They just fit together, and you can even print them in like you would hardware, stuff like that. And I wouldn't say the layer adhesion is like you're printing the two materials together, but there is some, and they work together pretty well.
Awesome. Have you seen the seam being pronounced? I see a number of questions on the seam and like moving the seam and seal based on the seam. What's your experience been so far?
It's yes, you're going to find it, but
Yeah.
at the same time, it's less so than other platforms. I'm sitting here looking at one of these at the same time, going, "All right, where is it?" I'm trying to find it. I can find it, but there's no pronounced thickness change around it. So it's pretty smooth. I don't I haven't needed to stagger them. I don't remember if that feature is available or not.
Yeah. Have you used the stagger seam feature on Onyx?
I have, and
What'd you think?
it's great. I've had parts that I actually struggled with or had to post machine, where I was essentially making a sleeve over another part, and yeah, with stagger seams, I got rid of that. Didn't have to do it at all. So that's why it immediately came to mind. I'm like, that's a great feature.
Yeah. Awesome. Yeah, I think the stagger seam feature is good for certain things. There's like if you have an annular part,
hmm
that's yeah, and you need it to be round without some pronounced edge. It's definitely helpful. I found with there's like some orientation things you could do, which is when I say that you have to do this orientation thing to make your part better. It feels like it's like a thing that I need to bring to our software team and be like, hey, can you automate this procedure? But I found that with some parts that have a corner somewhere, the seam is going to align with the back left edge of the part. So the furthest back left feature that exists when you're looking at the print bed in kind of like an XY. So like, whenever I have let's say just a square part, or a rectangular part, that seam there's a chance this one here. There's a chance that seam ends up going in the middle of the face. That's what we don't want. I think we've made software enhancements to like put it on the corner if possible, but sometimes if it's like around, it's like a curved edge, like there's a very slight curve to it, it'll put that seam right down the center of it. So what I'll do is just make sure that rotate it a little bit, and put that seam in the back, and then it'll locate there.
Yeah, that's a good point. That's kind of like these parts that I showed came out at coupling. The seams are sitting on the corner,
Yeah,
so you don't see it.
yeah. Um, let's see. What are some do you have any requirements for parts that you like you have to have you have to qualify the materials, you have to get them like approved, or how does that work for you?
It depends.
Yeah, yeah,
That's the short answer.
yeah,
We do have requirements. Essentially, there's a criteria for a high requirement AM part. If there is a safety implication, they're different. We may require destructive testing, or and at least for me, a lot of times I like to print tensile samples and test my stuff. I love the data sheets. I also love to retest things in a practical sense, because a lot of times if your part geometries are really small or strange, I'll print a really little bitty tensile bar and then a really big one and see how they line up. Just kind of build that experience with how do these perform based on what I expect, or how do they perform with different settings and different things. So that's kind of our general approach is produce some generic parts, get a baseline, and if something's high requirement, yeah, we'll for sure put some additional testing around it. But usually it's just getting the familiarity up front and using that as a guideline.
It looks like you've done Onyx and TPU. Have you done any metal and TPU or anything like that yet?
Yeah, so like I've certainly not printed together because that's not going to work, but like the
Yeah.
coupling I keep mentioning this part goes with, that's actually a metal printed coupling that this inserts into. And very similarly to how I mentioned, that's what's great about having a lot of Markforged platforms. Dimensionally, they're all basically super compatible. You don't have to over tolerance things. So yeah, these interface with Metal X printed parts. Like I said, I have done it with Onyx. I haven't surprisingly, I haven't done PLA with TPU. We print tons of Onyx, so that's where most of my experience lies.
These are questions that I think you can help us answer too. What are the tallest parts you printed with Onyx? Maybe talk about some of the overhang angles that you've had. Yeah, what's like the most significant overhang, or yeah, tallest part? Maybe some questions around that.
Well, yeah, as far as on Onyx for Mark II, I've filled that print volume completely, no, numerous times. That's really where it pushed us, off into borrowing X7 time and FX20. Because on that I've got, parts that span the print bed of an FX20 now, that we were certainly not printing before, but it's very common. I've got some parts we've printed here in just the past couple of weeks that are, full length of the print bed, and I've had them full height of the print volume of Mark II, full print beds, printed for 7 days, and no issues. As far as the overhangs question, I don't mind the supports, so I usually don't try and push that a whole lot. I use the kind of 45-degree rule a ton to avoid supports when I want to. But I have pushed some parts out, 50, 55. I've used some of the new ability to block supports at times where I've got smaller through holes, quarter inch or less, just leave the support out and leave those holes clean. There's times where that's been really useful. So, I don't think I've pushed the limits of that, but have used a lot of it. Like I said, I know I've pushed the print volume of Mark II many, many times.
That's awesome. I've got some parts here, and I think I just have them on kind of in the background. And yeah, hopefully, I think we'll continue to answer questions. But yeah, if there's anything here that I'm just gonna like, it's sort of like a nice background, nice background music or background visibility here. There's actually, I'm each time with these webinars, I'm trying something new, and I thought that doing some sort of like a fancy phone mount thing would be kind of cute, but maybe I'll just hold the phone.
There is one thing I'm sitting here staring at my pile of parts and looking at some of yours white there that kind of made me think of is, a lot of my other TPU, black was the only color. And that tends to be fine, but in this application we kind of showed, we made this thing really grippy on the outside with all these ridges, and it worked really well. Well, I don't know if it'll show up well on the camera or not, but the inside we started seeing it looks almost rust colored. We made the outside grip so well, we started slipping on the inside, and because we ran a batch of these in white, it was immediately obvious. We pull them off and went, oh man, those things are slipping, where the black ones you couldn't tell. So having the ability to do white even has had some functional benefit, and we're now working on another version with internal features to stop that. But without that, we probably would have never noticed. So just even having the two colors available has been useful.
Yeah, that's a functional thing that a functional improvement that I didn't even really think about. We've been using Onyx and everything's in black. It's been like that for so long that I forgot about colors.
Yeah, which I mean, even Onyx, the abrasion shows up pretty easy, but on a TPU part, it doesn't necessarily, because they handle it so well.
Yeah, it's always funny to see parts too that are like the ones that we had traditionally for strength demonstrations. This is that brake lever. It's like you see this kind of bending and flexing. It's kind of it's funny. There's like, I think the flexibility can be tuned, right, like by design. I think as we figure out some more software stuff, it could be interesting to see if we can simulate different infills or that sort of thing. There's the question around the tallest part that we've printed. I have a part here that's pretty tall. I'd venture to say that it's close to it. If I were a betting man, I'd bet that they scaled this part to fit in the Mark II, so that it maxes out at the 6 inches here. So yeah, it's a protective covering used to, looks like, to protect a component that they were shipping. And yeah, it's nice to have that flexibility. You were mentioning that you'd done some protective coverings as well.
Mm-hmm.
And I think we'll have to probably, for a lot of folks on the call who are asking about gaskets, we'll probably need to get more detailed information on that. Yeah, I can imagine that slight variances in infill could lead to leaking. You have like a difference in the flatness of the top, like that could lead to leaking. So that's something that we'll have to figure out probably. And if you have information on, if you've done this before, if you have if you've tried it before, what other techniques you used. We're looking at leak tightening other materials as well, right? So it's like metals, so leak tightening metals, leak tightening onyx parts. There are a number of things you can do. There's like post processing where you're cleaning up the surface. There's vacuum impregnation, which I think is pretty cool. You pull a vacuum, put your part in like an epoxy, and then draw it in. Charles, have you leak tightened anything? Whether that's TPU or not.
Not specifically. I've used some TPU in water applications, and they worked well enough for what I was doing.
Yeah.
Another thing, just looking at that gasket you've got laying there, something I have used is, and I do it in Onyx as well with the TPU part like this. A lot of times you can add wall thickness around bolt holes like that, so that you don't completely squish it, but you can have a non-solid part. So you don't necessarily have to use the default couple of walls. You might put 4 or 6 walls around your features to get variable stiffness on a part like that. I have used that kind of a feature before. Just came to mind looking at it.
Yeah, I think there's like a good amount of stuff that we can still improve on with TPU. It's, as I said, we release the material when it's ready, and then we continue to improve it from there. So yeah, Charles, as you go on using it, and folks on the call, as you go on using the material, we're curious what feedback you have to make this material better. Yeah, as I said, we've got Print Systems team, Lindsay, shouting out to you. We're gonna continue to improve this material. I'm not sure if I'm gonna close off the video here and just kind of focus on answering questions for the rest of the hour. The compatibility, as I'm not sure if it was like totally clear, but we're right now available on Gen 2, Mark II, and Onyx Pro. That means that you can check the back of your machine, and then your machine label will say whether it's Gen 1 or Gen 2. If it doesn't say it's Gen 2, then it's Gen 1. So unfortunately, it hasn't been qualified for use on that because it's the extruder is not as powerful as the Gen 2 extruder. In terms of upgrading the extruder, it's like this whole process of like having to disassemble and there's new wiring, new motherboard. Like it's kind of a tough process. And if you're interested in getting into a Gen 2 unit, if you have a Gen 1 unit and you're interested in getting into a Gen 2 unit, like get in touch with us. We want to make sure that the platform continues to work for you. No promises, but it's like we want to work with you on that. So this is from Eric. Eric is asking, what material did you print with previously that you now print with Onyx? For example, did you previously print PETG and PLA and just now print Onyx?
Yeah, but printed with both of those. Printed a ton of ASA prior to Onyx, and a lot of those materials, it was always, well, here's a prototype. And going to Onyx, it's now not a prototype. We're building the parts we need directly. Is what led us to that, or down that path.
Do you have any interest in fiber with TPU? That's I've seen a number of questions here on in the webinar chat about fiber and TPU.
Yes, I do. And that's where this kind of belt looking guy, if you run these teeth inward and I need a custom length belt, I would love to throw Kevlar in that for even more break resistance. Now, it wouldn't work for the application we spotlighted because it needed to expand. But if I needed flexibility without expansion, it sounds like a good fit.
Yeah, cool. I think it's pretty cool as well. I've seen a kind of hacked up R&D part, which was essentially, it was like a fiber part within an Onyx within a TPU part, and it's some pretty cool stuff. Like if you think about some of the elastomer, like conventional drive belts and stuff, it's an elastomer with fiber in it, right? So,
Yeah.
and any of those were that's like probably a good prototyping tool. What's the infill type that you use with TPU? Are you using triangular or are you going solid?
Yeah, I use
Diamond?
triangular a lot because I'm looking for the compliance. But it's, triangular, you're going to get the softest part. Gyroid's a little stiffer. And like I said, and if I need something in between, I start playing with wall thickness, all the way up to essentially a solid part. So you can get more or less whatever you need, and a lot more flexibility without having to design in the compliance necessarily, which was cool for us. A lot of times I don't want the cavities, so I don't collect dust or debris. So you can really span it from something that behaves more 60 durometer all the way up through its full hardness.
Let's see. There's more compatibility questions. So, it is compatible. So you have a Mark II. It's when did you get your Mark II?
So I got it kind of end of, let me think now. It was in 2019 when I got my Mark II.
Okay, you got in just as we. It sounds like you probably got in just as we did the Gen 2 transition.
Yeah.
So
one of the early ones.
Yeah, the Gen 2 machine started shipping in late 2019. So that's sort of when the changeover happened. If you have a machine from before late 2019, if there's a chance that it's a Gen 1, again, like you should get in contact with us if you're on a Gen 1 and like really want to print TPU. So it's not compatible with the Onyx 1. It will be compatible with X3, X5, and X7. The compatibility with Onyx 1 is a question. Seems like a kind of a sore spot that we've sort of we need to address. Right now, the main concern is just that we've qualified this for the machine, which essentially has 2 heaters on the end, and those machines are the ones which we're kind of prioritizing for development. There is a difference in characterization, so whenever we're doing print testing, like the heat up and cool down rates are different. Like you're going to get different print performance. We could qualify for Onyx 1, but we just haven't yet. We would prioritize Industrial Series first. And this is the whole thing, right? The machine that we're using is a Bowden drive. So we're pushing material like a foot and change, a foot and change from the extruder to the print head, to the nozzle. And so there's a lot of like magic that happens. I gotta say that our print tuning, the engineers that are doing print tuning, our systems print engineers, they're kind of wizards. I was so skeptical of being able to print TPU at the beginning. I was like, are you serious? We're gonna push that from there to there? You're gonna tell me it's not gonna string? Like I've seen so much stringy TPU that it's kind of hard to believe. Like Charles, is that kind of your reaction as well?
Yeah.
But it's if you can dial it in, it's like it's going to be harder to dial in, but once it's dialed, like the machine, it's very consistent for Onyx. It's also very consistent for TPU, and I think the reason why it's taking a little longer for industrial, well, the tube's a lot longer too, right? It's just taking longer to get from the extruder to the nozzle. So we need to figure that out, but so far, and like at least with preliminary testing, it's looking good. So I'm confident that we'll have it before the end of the year. Sort of plan is like November. Don't quote me on it, but that's sort of what I've heard. We've got an anonymous question here. Have we used it for a Shore 95A parts in the application of a spring strained to 200% original length? So how did it perform? I personally have not printed a spring yet, and I think we will probably see more of this as you go out into the world and print spring parts. But as a thought, Charles, how much are your belts needing to stretch before you put them on? Like, have you stretched parts? Like, what have you seen with that?
Yeah, I'm definitely not pushing them to 200%. Even in diameter. So these are about a 1/4 inch in diameter under what they are installed, and then they may expand up to essentially a 1/2 inch diameter change over roughly a 6 inch part there. I'd have to crunch on the math to tell you what percent that is. That's probably the part I'm pushing the hardest, and have been fine. Everything else where I've built, like kind of compression blocks or something, were just not that precise. I couldn't give you figures on them.
I've got my good pal Daniel Lazier on the call.
Mm-hmm.
Dan, thanks for joining. For those who don't know, Dan, haven't seen him in some of the YouTube videos. Daniel and I joined as application engineers around the same time in 2017, and he was a proponent for the small but mighty desktop printers. Dan was a collegiate cyclist, so he's trying to push his power to weight ratio, horsepower per pound as he called it, I think it's fun to see what more capabilities we can get, kind of squeezing out of the same footprint on the printer. Mark 1 was the same footprint as the Mark 2, but just continue to enhance capabilities through hardware, software, and materials. Dan's asking, what's the spookiest part you printed in Smooth TPU? What would you classify as a spooky part?
Spooky, yes, one. I don't know. Like I say, I'm showing all my favorite parts here. Spooky, I don't know. Yeah, I don't know. This is still my favorite one. The coupling. Yeah. I wish I had the rest of it. It's actually installed on a machine, and works beautifully. But and you mentioned the small but mighty Mark II. Without doing the math, I bet that machine has delivered more value than any other printer I've got. Pound for pound, what it can do is amazing.
Yeah, that's my feeling as well. It's like you think of it, probably when you first thought of it, it was like, okay, this came with my Metal X, right? So it's like, sure, thanks. We'll take it. We're not gonna say no, but yeah, it's like once you start using it, right? That's when you start when did that click? Was there a moment where you felt like it clicked for you?
Honestly, one of the first parts I made on it, I bet I'd had it for a month, and I needed a mounting bracket for something that weighed 150 pounds. Previously I'd have never thought to print it. I'm like, yeah, let's see what happens. And that was 2019. It's still mounted, still there, and it was like, this is absolutely ridiculous. I didn't have to go to a machine shop. I didn't have to go to the welding shop. It just immediately was like that printer became full, and I was ridiculous for not considering purchasing this long before the Metal X. It was really eye-opening for me. That it was honestly something I just missed on, and it wasn't on my radar until I had it in my hands.
Yeah.
Now it's like everyone should have one of those.
Yeah, it gives you a lot of capability options, which maybe previously you didn't think were possible with 3D printing. Maybe you didn't think were consistent to do in 3D printing. So a spooky part. I do have a kind of spooky part here. Now that I'm thinking about it, Dan. This is just I feel like it's just a puck, right? But if you look at it and you're like, okay, well, this is probably some sort of hard plastic, but you see it's got some flexibility to it. But it's a 95A TPU is still still fairly rigid. As you were saying, you had some parts, some pads which were being loaded under compression, and those were kind of holding up. The same print when you change the geometry of it, you can really get some weird flexibility. So it's like I think a lot of what I'm seeing is with flexible robotics, those types of things, as they're getting to be more, maybe they're trying to mimic more humanoid behaviors, right? You're putting it on the end of a robot arm, and you've got maybe you've got a tension line, which is pulling and allowing you to compress parts in a certain way. I think those types of things for me are pretty spooky. We're not far off from robots doing performing more flexible behaviors like a person would. There were some I would say that circa 2017 there were some continuous fiber applications where what we were looking at was printed parts which were giving you variable flexibility in a part. So you could have essentially you're printing a bit of a skeleton of a part and then casting urethane around it. So you could print a mold essentially put inserts in and then cast around it. But now, sort of what we're saying is you might be able to print the whole
Yeah,
thing. You might not even need to bother with like a urethane casting.
exactly. And that's what we're seeing. At least if the geometry is amenable to it, it works well.
Yeah, yeah. Definitely. There are certain geometries which are just probably not going to print particularly well.
Yeah.
Yeah. Well,
But yeah,
cool.
I'll say
I think.
without being able to block support
Yeah.
and print pause, which are both pretty new features. You couldn't do it, but now you can do it.
Well, awesome. We're 15 minutes over. For the 110 people who are still here, thanks for sticking around. For those of you who didn't get your questions answered live on the call, we will make sure to get an answer to you. My guess is that the customer success team, Kat, Michelle, and company and Ron will probably reach out to you. So thanks again for joining, everyone. And Charles, thank you so much for taking the time
Yeah.
with us today to tell us about your experience. Any closing remarks from you?
No, appreciate you guys having me on here. Hope it's helpful for some folks to hear about these things, and yeah, good luck printing with TPU.
All right. Cool. Thanks, everyone.